and we are here to showcase our final project presentation aimed at establishing predictive analytics for enhancing mission maintenance and optimization. This slide briefly gives description on each team member and their crucial part involving their participation in the project. Coming to problem statement, our primary aim is to establish a predictive maintenance system that can precisely forecast the potential failure and uninterrupted operation of a specific mission. Also, this predictive capability plays an important role in upholding the reliability and optimization performance of the industrial machinery. This model also addresses the critical concern of minimizing costly downtime in industrial operations. So by forecasting the potential failures, we help teams fix problems before they happen. This basically saves the time and resources by avoiding unexpected breakdowns.
It is very important to solve this business problem, and as it will lead to several negative effects, like the production will be stagnated if there is any downtime. Eventually, it will lead to the deadlines will be missed, and the revenue there will be a loss in the revenue. There is a need for sudden repair and replacement of the machinery that will lead to the increase in maintenance cost and eventually the budget. And the overall customer trust and reputation will be compromised. And in this competitive industrial world, such downtime will define the success and failure. Hence, it is very important to solve this business problem and to find a robust and effective solution.
So now let's discuss the modeling, how this modeling helps in identifying and tackling this machine failure issues. So we can preemptively identify problematic machines that directly impact reliability and revenue, which are important factors in this particular industry. Hence, we can rectify any issues in the supply chain by this analyzed data. So any organization can develop plans to maintain their equipment and upgrade them in a timely manner. By using this historical data. And coming to the confusion matrix. Here I'll be telling about how we evaluated the solution. So the true positive here is, in our case, is if the machine actually is working fine and the model also predicted that the machine is working fine. That's the true positive in our case. And true negative here is the machine actually failed and the model also predicted that the machine is failed. And these two are the correct values. And coming to the incorrect values, which are false positive. Here the machine actually failed, but the model predicted has not failed, which leads to the increase in operational cost and other maintenance charges, while false negative means the machine didn't fail, but the model predicted the machine has failed, which leads to decrease in productivity and financial losses. So here both false positive and false negative causes loss, but false negative leads to more loss. So we have to reduce a false negative, and it is very much essential. So we have choose recall as our primary evaluation metric, and we have implemented few machine learning models and choose the best model among them. And now Yogesh will continue with the rest of the presentation.
So coming to the data set description. So the features are designed to simulate real-world conditions with factors such as temperature, rotational speed, and torque, which exhibits random conditions. Mission failures can occur due to overheat, power issues, and overtrain, and random failures associated with it. In this data set, it contains around like 10,000 data points, which are represents like 14 futures in these columns. Dataset is licensed with a license under the Creative Cloud Distribution 4.2 International license, and these are the factors we use in this project. And our target is like mission failure level, a level which is a binary variable which indicates the mission failure. Coming to the model. So this is the data model which we performed during our submission. So starting with importing data, followed by data processing, we did data exploration with PySpark SQL, and later on feature engineering. We did text and split with some machine learning models, and we chose classification for predictive maintenance. In this, we choose like logistic regression, decision tree, linear SVC model, and random forest. Later on, we did the model evaluation and interrupted the model.
So now the code part will be explained by me. Let me navigate to the code base. So here we have started the Spark instance and followed by importing the data. As you can see, this is the data structure. We have 10 columns, and there are two categorical variables here, which is the UDI and the product ID. So we have inspected the data here, and the results can be shown. And yeah, the data cleaning and processing have been done here. We have checked for the missing values in the data set and found that there are no missing values in either of the columns that are present in the data. Since the product ID and the UDI are the unique values, which are really unnecessary for the model evaluation. So we have dropped these columns for the optimal computation of the model. And we have explored the data using the SQL queries here. We have listed 8 SQL queries. So this lets us know about the data validation and the data characteristics. We have ranged the queries from simpler to complex. So these are the queries. And yeah, now to perform the train and the test split, we use the 70-30% standardization technique here. So with that technique, we have performed the train test split, followed by the feature engineering, where we first checked for the data imbalance. As we can see here, the number of ones that are present in the data set are 247, followed by the zeros, which are 6,713. That's a huge discrepancy between both the target variables. And we have performed the oversampling technique here. So after performing oversampling, we can see that there are equal number of zeros and ones that are available in the dataset, which is really feasible for the model evaluation. And there is a variable called type in the dataset, which is categorical. Since the model cannot evaluate the categorical data, we converted the categorical data into vectors. So first we have done the type indexing here, followed by one hot encoding. That step is seen here. And later we have dropped the type column since we have the vector representation of the particular column that is available. So later we have performed the assembler, which combines all the feature variables that are present in the data. And this is basically the collection of all the feature variables. So we have standardized the feature variables in all the vector format, and later performed the model implementation and evaluation. Firstly, we have done the model fitting on decision tree classifier. So we have performed the pipeline technique here. Basically, a data pipeline is a set of data pre-processing steps that are executed in the specific sequence. So we can see that all these processes will happen in a sequential manner. And it is very crucial in the big data for its role in enabling efficient and parallelized automated processing. And it also provides optimal resource utilization and facilitates scalability and adaptability. So that's the important use of pipelining in the big data. And later, after performing the model evaluation, we can see that the area under curve is 0.95, which is 95% here. And it is quite high and generally indicates the excellent discriminative ability of the model. So the area under the precision recall curve states that um, it works quite well with the imbalanced data set, and um, it is also relatively low and suggests that the model may be struggling to achieve both the high precision and high recall across different classification thresholds. In the same way, we have computed the computation metric and provided the results of all the available metrics. In the same way, we have performed the computation using random forest classifier, linear SVC model, and logistic regression. The results now will be explained by Naveen.
Hi, this is Naveen. Today I'm going to present the results of our analysis on predictive maintenance using the AI 4i 2020 dataset. Our objective was to proactively identify potential machine failures in an industrial setting. After evaluating 4 models, decision tree, random forest, linear SVC, and logistic regression, based on the recall metric, we observed impressive results. The decision tree exhibited a remarkable 97% recall, which is shown in the diagram, indicating its efficacy in identifying machine failures. Although we must be cautious about overfitting, the random forest and assemble of decision trees achieved a slightly lower but robust 96% recall, demonstrating its effectiveness in reducing overfitting. Conversely, the linear SVC struggled with a 76% recall, possibly due to challenges in capturing nonlinear relationships, while a logistic regression achieved a 80% recall. So among them, we consider decision tree as our best model due to its high recall score. And feature importance analysis and addressing class imbalance are crucial steps in achieving this. As we delve deeper into model comparison exploration, so these are the results. However, the journey to these achievements was not without its challenges. During our analysis, we encountered a significant calculation error in the logistic regression model, initially posing a substantial hurdle. Through meticulous investigation and debugging, we successfully identified and rectified the error, ensuring the integrity of our models. Additionally, we faced file transfer issues caused by the instability of virtual machines hindering the smooth transfer of data. Overcoming this challenge required implementing robust solutions to stabilize virtual machines, and establish a reliable data transfer mechanism. Furthermore, setting up and configuring the Java environment proved to be a task in itself, demanding careful attention to detail. In conclusion, our predictive maintenance model, particularly the decision tree, has made remarkable strides in improving operational efficiency and reliability by minimizing unplanned downtime. The challenges we faced, including addressing calculation errors, stabilizing virtual machines, configuring the Java environment, were formidable but were successfully navigated. We are excited about the positive impact our models can have in real-world industrial applications, and we look forward to further refining and implementing them to revolutionize predictive maintenance strategies. Thank you for your attention.